So today I thought I would do a short video on another technique of differentiation, and it's called logarithmic differentiation. It's not something you're going to use like the chain rule or the product rule, but it's a very helpful rule at times. So we're starting out with a fairly complicated function, y equals this divided by this. And we're going to do something that's a little bit counterintuitive. You would think we would want to differentiate this explicitly. It's already solved for y. But we're going to do something, we're going to take the natural log of both sides. And now we're going to do it implicitly. And the reason we're going to do that is we're going to take advantages of these nice properties of logarithms. They turn multiplication into addition, they turn division into subtraction, and they turn exponentiation into multiplication. All things that are easier to do derivatives with. So before we do the derivatives, I'm going to take the natural log of the numerator divided by the denominator. So we're going to use this property right here to say it's the log of the numerator minus the natural log of the denominator. And the denominator is 1 plus x squared to the fourth. And you can see just in here that we can then take advantage of this property and bring this 4 out front. Now, for the numerator, we have the natural log of x squared times this. We can use this property and say it's the natural log of x squared plus the natural log of 7x minus 14 to the 1/3. So we haven't done anything but take the log of both sides and then use the property of logs to simplify this. And we can bring this 2 out front, and we can bring this 1/3 out front. Now that we've done that, now we take derivatives of both sides implicitly with respect to x, because we're trying to find dy dx. So the derivative of the natural log of y is 1 over y prime. Well, that's what we're trying to find right there. Is y prime, dy dx. Let's see if this made our differentiation easier. The derivative of the natural log of x is just 1 over x. And again, the natural log of this would be 1 over that function times the derivative of that function. We're just doing the chain rule. And then we have minus 4. And again, we do the chain rule. 1 over 1 plus x squared times 2x. Now, since we want to solve for y prime, we now have to multiply both sides by y. So I cross that out. And this is what I'm trying to solve for. And what is y? Y is what we had originally. So it's x squared times the cube root of 7x minus 14 all over 1 plus x squared to the fourth. And this whole thing right here is the derivative. But I think you can see that that would have taken quite a while if you did quotient rule and product rules and chain rules all kind of intertwined up here. So I could simplify this a little bit, but I think you've seen the advantage of what you can do with logarithmic differentiation, just making things simpler. Now, something that might even be more valuable is, because we could have done this one with all those other rules, if we get a function where we have y equals a function to a function power, logarithmic differentiation is the only way we can take the derivative. So that's why I say it's even more valuable. There's no rule that allows you to take x to the x squared power. So what I'm going to do is take the natural log of both sides, and then I can take on this, I can take the x squared and put it out front. And now, implicitly, I can take the derivative, just like I did up here. I get 1 over y prime, and now I've got to do the product rule. So I go the first times the derivative of the natural log of x plus the natural log of x times the derivative of x squared, which is 2x. So altogether, y prime is x plus 2x natural log of x, all times the original y, which is x to the x squared. And we've done it. If you wanted to find y prime at some point, you would just plug it in. Okay, let's try one more of those. X to the sine of x. We're going to take the natural log of both sides, and when we take the natural log of this side, we're going to take the sine of x out front. And then we're going to do the product rule again. So 1 over y prime equals the first times the derivative of the second plus the second function times the derivative of the first. And then we can multiply both sides by y. And we've got our answer. X to the sine of x. But this time we want to find the slope at x equals pi over 2. So y prime of pi over 2 is the sine of pi over 2, which is 1, times 1 over pi over 2, which is 2 over pi, plus the cosine of pi over 2 is 0, so that just 0 times pi over 2 to the 1. So altogether we get 2 over pi times pi over 2. The slope of this function at x equals pi over 2 just turns out to be 1. So isn't that a nice result? So that's all I'm really going to teach you about this. It's a very important, but it just isn't used as often type of differentiation. So, thank you.